Welcome to this explainer. Today we're unpacking a really fascinating concept, and it's called correcting the source. We've all heard the promise, right? AI is supposed to make our workflows incredibly fast and super efficient, but actually, right now there's a massive, expensive trap that software developers are falling into where they use AI, and ironically, it's slowing teams down. To understand how to dodge this, we're going to start somewhere kind of unexpected, a middle school classroom. It's a simple story, but I promise you, it holds a massive secret for literally anyone working in modern software development.
Okay, let's dive into this. So, picture this scene. A father is visiting his son's school for a completely standard parent-teacher meeting. The teacher welcomes him in, sits him down, and says, "Your son wrote an excellent essay yesterday. Would you like to see it?" Naturally, the father is incredibly proud. He looks down at this open notebook on the desk, reads through a beautifully written, perfectly corrected essay, and just absolutely beams. But then, after a few minutes, the teacher smiles and throws a bit of a curveball. She asks, "Can you ask your son to recite the essay from memory?"
So the son stands up, takes a deep breath, and confidently starts speaking. But to the absolute surprise of his dad, the words coming out of the kid's mouth are entirely different from the pristine, polished essay written on the pages of the notebook right in front of them. The spoken phrasing is kind of clunky, the facts are slightly off, and the grammar, it's a total mess. The father just sits there, looking back and forth between the perfect notebook and his son, completely and utterly confused. So the obvious question here is, why on earth did the son memorize the wrong version? I mean, how do we have this massive disconnect between the beautifully finalized essay sitting right there on the desk and the student's actual memory of the material? What went so wrong between the drafting phase and the memorizing phase? Well, the father finally stops his son, points to the desk, and asks the obvious question. Why is your essay different from what's written in your notebook? And here is where we get the twist, and honestly, the crucial lesson for our explainer today. The son replies, "Yesterday, my teacher corrected many mistakes in my essay. I changed the notebook, but I never updated the notes I originally used to prepare it. Today, I memorized the old version from my notes instead of the corrected one." Wow. Think about that for a second. The student had put all his effort into polishing the final output, but when it came time to actually study and retain the knowledge, he went right back to his original, deeply flawed source material.
The teacher chimes in to explain the harsh reality of this little habit. She points out that if he keeps studying from those old, uncorrected notes, he is absolutely guaranteed to make the exact same mistakes on every single new essay. The father nods, having this immediate realization. Every future essay will require the exact same corrections again, because the source itself was never corrected. The teacher confirms exactly that. Just fixing the final product, it simply isn't enough. The original source of knowledge has got to be updated.
Right, so let's shift gears now, because this strange little classroom parable perfectly mirrors the daily reality of highly paid software developers right now. No joke, we are seeing the exact same dynamic play out in modern AI-assisted coding, and it is quietly but surely draining productivity from engineering teams all around the world.
Let's look at the standard, but fundamentally flawed workflow happening in development environments everywhere today. Step 1. A developer asks an AI assistant to generate code for a new feature. Step 2. The AI does its job and outputs that initial code. Step 3. A senior developer reviews the pull request, spots the inevitable issues, and leaves some review comments. And Step 4, well, this is the critical failure point. The developer goes in, gets tunnel vision, manually fixes the code to satisfy the PR requirements, but completely ignores the AI's context window. They never tell the system prompt what went wrong. They just patch the final product and merge it. So what happens the very next day? The developer sits down with their coffee, opens up their IDE, and asks the AI to generate another feature. Think about it for a second. Based on what we just learned from the student and his essay, what do you think is about to happen here? The developer has a shiny, fixed piece of code sitting in the repository from yesterday, but they left the artificial intelligence totally in the dark about those vital fixes. Because the developer didn't feed the corrections back into the system, the AI relies on its previous context window and its previous coding patterns. It essentially memorized the old notes. So what does it do? It repeats the exact same coding mistakes. It regenerates the exact same flawed logic. And that means the frustrated senior reviewer is going to have to pull up this new PR and agonizingly type out the exact same comments all over again today.
And this brilliantly illustrates the massive waste happening in tech right now.
The consequences of this broken loop are actually pretty severe. We're talking repeated coding issues, highly frustrating review cycles, and entirely avoidable rework that cascades into massively increased development costs. Highly skilled teams are basically spending their valuable time running in endless circles, fixing the same bugs over and over, all because they're treating the AI like a disposable one-off tool instead of an evolving learning partner.
The mapping here is incredibly clear. Updating only the code manually is exactly like the student only correcting his homework notebook. It looks really good for today's assignment, but it does absolutely nothing to help tomorrow's. But updating the AI's context with that feedback, now that is like correcting the actual study notes. By updating the prompt or the knowledge base, you ensure tomorrow's output is fundamentally smarter than today's.
So the crucial point is this. If you take away just one thing from this explainer, let it be this defining principle. Every single code review must improve not only the code, but also the AI prompt, the context, or the knowledge base that generated the code in the first place. You literally cannot just fix the final product. The source itself must always evolve. If you don't update the context after every review, your team isn't actually preventing mistakes. They're really just getting exceptionally fast at correcting the exact same ones on repeat.
Which leaves us with one final provocative question to ask ourselves about how we work with these incredible tools. Look at your own daily workflows. Look at your team's pull requests. Are you actually preventing mistakes, or are you just repeatedly correcting them? Are you fixing the notebook, or are you fixing the notes? It's time to close that feedback loop. Thank you for joining me for this explainer, and I highly encourage you to go update your source material today.